Now, what we frequently have to do when we have formulae is to transpose the formula, to rewrite the formula in a different format. If I want to program a calculator or a computer, I would have to do that. So we have to be well trained in that. Let's have a look. Transposing, that's what it is called. In transposing, what we do is we change the subject. In a formula such as f equals m times a, we actually call f the subject. It is the letter that's on its own, if you want. And to make another letter the subject, you transpose or you solve the formula. So, for instance, if I have f equals m times a, I could write it as a equals f divided by m. And now that is the subject. Or I could write it as m equals f divided by a. Now, the process for doing this is very similar to solving algebra equations. I've got an example there. If I had to solve in algebra 2x plus 7 equals 15, and I have to solve that for x, and I compare that with, for instance, c equals 2b plus h solving for b, I go through the same steps. See, for the first line, I rewrite the equation, then I transpose this 7 to the other side to make it 8, so I end up with 2x equals 8. In this case, I want to transpose the h, and I end up with c, subtract h equals 2b. From this I get 8 over 2 is equal to x. A little bit more difficult, of course, with these letters, but the same operations apply. If I want to get b, I have to divide the whole left-hand side by 2. I get c minus h over 2 equals b, and that's all I can do with my transposition. I can certainly calculate that x equals 4, but I can't do anything here. That is the end. That is the transposed version of this formula. As usual, let's have a look at some examples. Here we've got problem 1, that's a problem used in mechanics. Phi equals u plus at. We must make t the subject. So rewriting that, we transpose the u to the left, it becomes a minus u. Then I divide by a, and I get phi minus u on a equals t. Rewriting it perhaps, that's the transposed version, phi minus u on a. Second problem, where we've got the formula for the perimeter of a rectangle. We know we want to evaluate w given p equals 18 and l equals 2. So I want to transpose first before I can evaluate what w is. That's what I'm doing right here. I write it as 2w equals p, subtract 2l. I've transposed the 2l. In other words, I then divide by 2 to get the transposed version of the formula. Now it's just a matter of substituting 18 in there, and 2 times 2 there becomes 4 to get the answer of w equals 7. Let's have a look at number 3. This is indeed a little bit more difficult. This involves the square root. Now, to undo square roots, use square. And that's what's done here. I've squared that term, but I first transposed the 2a. And so I end up with 2 times p a, because I multiplied the 2a by the p, equals the square root of 2r minus 3. Squaring both sides gives me 2pa all squared equals whatever was underneath the square root. Then we turn to the next page. And we multiply that out, difficult one, that becomes 4p squared a squared equals 2r minus 3. Finally, transposing that leaves me with the transposed version of the formula, substituting the values that were given into the formula, and that gives me the value of 100.